Hello everyone, welcome to the Modern Networking lecture series. This is lecture number 3. In the previous lecture we saw the Ethernet standard, and in continuing with that we now do the topic that is 4G, 5G, because these are some of the driving forces. Okay, high speed networks and high speed connectivity, these are now the driving forces for running towards the modern networking. So this 4G, 5G cellular network, this cellular technology is foundation for the mobile wireless communication. We call it a cell phone because every operator, it divides the geographical area into number of cells. So this particular cellular technology is one of the foundations of mobile wireless communication, and it supports users in locations that are not easily served by the wired networks. Okay, so there are some locations where we cannot provide wired connectivity, so we can even use this particular cellular network to provide the networking at that particular area. Then this is one of the underlying technology for mobile phones, personal communication systems, wireless internet and wireless web applications. Now this technology has evolved to the 5th generation. Let us see what are the 5 generations. The very first generation cellular networks. So this first generation mobile, they provided analog traffic channels, okay, and they were designed to be an extension of public switch telephone network, that is the landline phone, what we call. So this first generation, they were actually analog traffics. They provided the analog traffic channels, and they were actually provided support for the already wired telephony, that is we call as landline phones. Now in that case, in the first generation telephone cellular networks, the users, they had a very large brick sized cell phones which could receive and of course we can call and receive calls, place and receive calls similar to the landline subscribers. The most widely developed IG was the Advanced Mobile Phone Service, that is AMS, which was developed by AT&T. Okay. The voice transmission was purely analog. Okay, this voice transmission was really analog, and controls were sent over 10 kbps analog channels. Okay. So this was regarding the first generation. Then after this we had the second generation cellular networks. So this 2G systems, they developed to provide high quality signals. Of course they were high quality digital signals, so higher data rates to support digital services and greater capacity. So then this second generation, what the aim was to turn to the digital technology, and also to provide not only voice but also to data. Okay, so the main difference between the IG and 2G networks include the digital traffic signals, then encryption. Okay, so the main difference it is between 1G. So 1G was actually analog, and this was digital traffic signals, and encryption was also used in 1G telephony cellular networks. Encryption was not done, so here encryption was done to provide confidentiality. Then there was a provision for error detection and correction in case of 2G, and channel access. So in case of 1G, the channel, one of the channel was a single channel was used by a single user, but in this case, in case of 2G, a single channel, we could have multiple access of the same channel. Okay, so multiple users could use the same channel, okay, through some multiplexing techniques. Then we had the third generation cellular networks, which is called as 3G. So 3G of wireless communications provide fairly high speed wireless communications, which could support multimedia, data, video in addition to voice. Okay, now 3G systems, they share the following features. So the bandwidth, that limited the channel usage to 5 megahertz. So a bandwidth of 5 megahertz or more, it improves the receiver's ability to resolve multi-path when compared to narrower bandwidth. So this bandwidth was increased. Okay, so the second benefit was the available spectrum is limited by competing needs. Okay, so there can be other carriers. Okay, so this, if we limit the bandwidth to 5 megahertz, then we can support multiple carriers. Okay, and this 5 megahertz was enough to support data rates up to 144 and 384 kbps, kilobytes per second. And the second one, this was the bandwidth part. The second part is the data rate. Now the data rate, typically it could support, this was the standard one, but some 2G, 3G, they supported up to 2 Mbps for office use. Then the term multi-rate also refers, we had this multi-rate in case of 3Gs, So this multi-rate, okay, the advantage of multi-rate actually is that support multiple simultaneous applications for a given user. Okay, so different rates are provided for different logical channels. So this multi-rate provision, which was in 3G, it supported multiple simultaneous applications for a given user. One of the application, it may require some data rate, the other may require different data rate, so it supported that particular provision. It gave that provision. Then efficiently use the available capacity by only providing the capacity required for each service. Okay, so this was there was an efficient use of the available capacity, so that whatever the capacity required for the service is only provided, not more. Okay, then we come to the 4G cellular networks. Now 4G, they provided ultra broadband internet access for a variety of mobile devices such as laptops, smartphones and tablets. Now it also supports mobile web access, high bandwidth applications such as we have HD mobile TV. Then it can support streamless mobile video conferencing and gaming services. Okay, now 4G, the main purpose was to design the system such that it could maximize the bandwidth and throughput, and also maximize the spectral efficiency. These are the characteristics of the 4G systems. So it was based on all IP packet switch network. Okay, this landline supported actually circuit switch network, but this 4G, it supported the packet switch network, and it supported the data peak rates up to 100 Mbps. Okay, and in some cases maybe like 1 Gbps for low mobile access was also available. Then it could dynamically share and use the network resources to support more simultaneous user per cell. Okay, so per cell more number of users were supported. Okay, because of the capacity. Then it supported smooth handovers across heterogeneous networks. So in case heterogeneous networks, and handover means what? If a person is just switching from one cell to other cell, so there are cell towers which are there in a single cell. So in case if the user is switching from is in transit, that person is moving, okay, in such a way that that person is going from one cell to other cell, then that there is a process called as handover, so that the person gets a smooth call, can receive smooth call. And it may also happen that the person is using is in a particular area where mobile network is not available, and that person is using a satellite network. So in case when the network becomes available, so it could easily switch over from satellite network to the mobile network. That is called a smooth handover. Then it supported high quality of service for next generation multimedia applications, and it only provides IP telephony service. Okay, because 5G systems, they are all IP packet switch network, and they are not circuit switch networks. Okay, next comes the 5th generation cellular networks. Now, because of the huge data traffic generated by tablets, smartphones, and more number of data, more and more devices are added. We have sensors, actuators, etc., which come from the Internet of Things. So 4G is also insufficient. So we need to switch to 5G. Okay. Now the focus of 5G will be like it will more intelligence into the network. We need to bring the intelligence into the network. So okay. Then meet service quality demands by dynamic use of the priorities. Okay, and adaptive network reconfiguration and other network management techniques are used to just handle this 5G cellular networks. Now next topic is the cloud computing. Okay, this is also one of the driving forces behind the modern networking. So this cloud computing actually dates back to 1950s, but it only became available in the early 2000s. Okay, and it was targeting the large enterprises. Now cloud computing has spread into small and medium sized businesses and most of the customers, of course, and you can see that in 2012 Apple's iCloud was launched, and within few weeks they had 20 million users. Okay, so this became very famous amongst the users. Okay, and even in case you can see Evernote, the cloud based note taking and archiving services, launched in 2008. It approached 100 million users in less than 6 years. And in 2014 Google announced the Google Drive. Now it is having almost more than around billion users, active users. Okay, Now the cloud computing concepts. NIST, which is the National Institute of Standards and Technology, it defines the essential characteristics of the cloud computing as follows. There are the 5 essential components of cloud computing according to NIST. The first one is broad network access. Okay, so what is the meaning of broad network access? It is that we can access the cloud services through varieties of heterogeneous devices, heterogeneous platforms such as mobile phones, laptops, PDAs and other traditional software services. We can access them through varieties of devices. Then the second characteristics according to NIST is the rapid elasticity. Okay, now what does it mean? So this cloud computing, it enables us to expand and reduce the number of resources according to the requirement. Okay, we can just scale up the resources, scale down the resources according to our requirement. So it is rapid elasticity is one of the characteristics. Then we have measured service. Okay, so cloud systems, they have the capability that they can automatically control and optimize the resources according to the metering capability. Okay, so resource usage can be monitored, it can be controlled and reported. Okay, which can provide transparency between the provider and the provider and the consumer, so that it can make the best utilization of the resources. Then we had on-demand service, self-service. Okay, so in what does this mean? Actually, a customer can unilaterally provision computing capabilities. Okay, so the consumer or the customer, or we can say the client, that requires the server time or whatever resources. Okay, so those resources which are needed, okay, they can be acquired without any human interaction with each service provider. Okay, so on demand the resources are granted. Then we have resource pooling. Okay, the fifth characteristics. So the provider's computing resources are pooled to serve multiple consumers using multi-tenant models. So we have something called as multi-tenant model here. Okay, so in this case, actually the resources, they may be located to different geographical locations. So with the abstraction, the customer or the user, okay, the client may not know where the exact location of the provider resources would be. Okay, of course, if we have at the higher level of abstraction, the locations can also be specified. Now the resources, which include the storage, processing, memory, network bandwidth and virtual machines. So each private cloud, even in case of private clouds, they tend to pool the resources. Okay, the resources are to be kept ready, so that whenever the demand arises, they can be given to the particular user. Okay, now this is the cloud service context. As we can see, this is the cloud provider. Okay, it is connected, okay, to the, this connection can be to a private network or to the internet. Okay, and here we have the users. Okay, this is the cloud, again this is a typical cloud user. So this cloud user is accessing the cloud service from this is the cloud provider. This, the arrow which I am marking, this is the cloud provider and this is the user. Okay, so the cloud provider can have a pool of resources, okay, various resources which are available, okay, and the user can access that resource. So this is the infrastructure. Okay, then these are the benefits of cloud computing. So cloud computing, it provides economies of scale, professional network management and professional security management. Okay, then the individual or company which is using this cloud computing service, it needs to pay only for the storage capacity and services they need. Okay, so whatever the demand, whatever the service which is used by the user, that is only charged and not much. And the user, which can be company or the individual, does not have to set up the database systems. Okay, so that everything is done by the cloud provider. Okay, then for providing the database, we require the hardware. Okay, we need to do the maintenance and all backup of the data. This all things, they are done by the cloud provider, not by the users. So this hassles, they are not to be done by the user. So this is also one of the advantage. We just use the service, and whatever the things which are required to provide the service, they are of course done by all the maintenance work and acquiring those SIMs, they are done by the cloud provider itself. Then the cloud provider takes the care of the security. Okay, in case if you need to share the data Okay, so when the data is in transit or when it is stored on the medium, security comes. Okay, so this security provision of the security is done by the cloud provider. Okay, the user need not need to worry about the security part. Okay, then we have something called as cloud networking, the concept which is related to cloud computing. So this cloud networking, it refers to the networks and network management functionality which must be in place to enable cloud computing. So to enable the cloud computing, we need networks and network management functionality. So this is called as the cloud networking. So one example of cloud networking is the provisioning high performance, high reliability networking between provider and subscriber. So we need a high performance and high reliable network. Okay, high performance because large amount of data may be shared, and high reliable because if in case of a failure of any of the resource, other can take up. Okay, so failure of a single resource or some resources may not need to the failure of the entire service. And this cloud networking in general, we can say it refers to the collection of network capabilities required to access a cloud, which can be of course making use specialized service of the internet and linking the enterprise data centers to a cloud using firewalls, etc. Okay, then we have one more concept which is related to cloud computing, is the cloud storage. So we can think this cloud storage to be a subset of cloud computing. So cloud storage, it consists of the database storage and database applications which are hosted on remote servers, cloud servers. Okay, so this cloud storage, it enables small businesses and individual users to take advantage of data storage which can scale with their needs and to take advantage of variety of database applications without having to buy, maintain, manage the storage assets. Okay, so this with this cloud storage, individual users or the businesses, they can get an access to the data storage, they can access to variety of database applications, and of course they don't need to buy or they need to maintain and manage the storage assets. These are done by the cloud providers. Okay, so that's next topic would be Internet of Things. So I will stop here. So I'll just stop this session here and we'll continue with this topic, Internet of Things, and one more topic in the next session. So that's all for this particular session. Thanks for watching.